Converting game consoles into portable versions has been a challenging undertaking for modding enthusiasts. But most portable mods are of smaller, less power-hungry consoles. So what if I wanted to make a current gen console portable? I may not be the first to try portabilizing the PS4, but let's see how small I can make it. I've chosen the PS4 Slim, not only because it's the smallest, but because it uses far less power than the original. But also one of the later model numbers, as they have slightly smaller motherboards and a smaller heatsink, which not only saves space, but most likely means a lower power consumption. This PS4 only uses 42 watts at standby and about 80 watts whilst gaming, but that's with an optical drive, which is obviously being left behind due to size. Let's strip this down and see what we can remove. The power supply makes up almost a quarter of the whole console. Its role is to take AC current from the outlet and convert it to DC current, so it's not necessary if we're adding a DC battery pack. We just need to match the two DC voltages that the power supply outputs. Now I'm not going to try and trim this motherboard down, seeing what I can cut off and still have it work, like expert modders have done with other consoles. So the footprint of the portable is going to be roughly the same size as the motherboard. Other than the motherboard, we'll need a controller, a battery, a screen, a cooling system, and a power management system. I'm going to remove all the unnecessary ports to save space. The SATA port sticks out too far, so I'll remove that, along with the Ethernet port, HDMI, auxiliary port, and some of the components that were only needed for those ports. Plus I'll remove one of the USB ports. I need to keep some of the metal shields for heat dissipation, but I can trim them down a bit. You may have noticed I cut off the hard drive shields. The mechanical hard drive takes up too much space, uses too much power, and is vulnerable to jostling, aren't we all? So I'll replace it with an M.2 drive. An even smaller M.2 drive. For this, I need an M.2 to SATA adapter, which is annoyingly the same size as the old hard drive. To the Dremel! There we go, that's much better. Now rather than make custom controls for this portable, I'm going to squash a PS4 controller into the build. Let's see if the DualShock works plugged in without the battery. Yes, awesome, and it only draws 0.10 amps. I don't need the rumble motors, essentially only the motherboard and the buttons. But obviously I'm going to need to relocate all the controls. I'll strip all the connectors off the board to make it as thin as possible. Now it's nice and thin, ready to squeeze in somewhere. I'm not sure how to separate the carbon flex buttons to relocate them, as you can't solder wires to it.
We will cut the
Controller
down the middle and give half to each of you.
This carbon circuit normally presses up against the contacts on the motherboard, so running them across the console isn't possible, unless I splice them together, which is a bit janky. But then I found there was a DualShock controller model which has separate connections for left and right controls, with separate ribbon cables to match. I just need to harvest these contacts, so I can then run wires from the boards to the original controller motherboard. Then I'll clamp the carbon contacts down with some 3D printed brackets. As for the analog sticks, I'll design a simple board to mount them. That I can then get printed by PCBWay for only $5 for 10 boards. PCBWay are the experts in custom circuit boards, from standard PCBs like I'm ordering, to advanced PCBs, flexible PCBs, and even an assembly service for lazy SOBs. Their easy ordering page and helpful support make ordering your circuit boards a breeze. Okay, we need a screen, and I found a suitable 7-inch IPS LCD for $75, which has HDMI, speakers, a headphone jack, and volume control. I was disappointed though, as the aspect ratio meant the screen was cropped. But then I discovered I just needed to change the resolution to the unsupported 1080p, and now it looks great, and only requires about 400 milliamps. Of course, I want to slim it down as much as possible. I don't need this fan socket. I don't need the headphone jack as I'm using the one from the DualShock. I'll remove both HDMI ports, and the volume wheel needs to be relocated. Actually, I'll just lop off this whole part of the board so I can mount it elsewhere. Rather than mess with the whole cooling side of things, I'm going to keep the original fan and heatsink. Now the screen's going to go here, the controls here, with the joysticks below them, and the speakers in the bottom corners. The top right corner of the motherboard conveniently has a cutout where the right trigger can sit. But inconveniently, the left side doesn't. Yet. I didn't want to delve into motherboard trimming on this build, but the triggers would need to sit up much higher otherwise. I tentatively sanded it down, just so I can see if there are any obvious traces I was cutting through. Nah, looks like we're okay. Lithium-ion batteries are 3.7 volts, so I'll be putting 3 in series to make the 12 volts needed. And to cope with the heavy power draw, I'm using 3 sets in parallel, totaling 9 18650 cells for a 116 watt-hour battery pack. Ideally, I would add in a voltage regulator so the battery pack would supply a stable 12 volts, but I definitely don't have room for the large 10 amp regulators. So that means the battery pack voltage will drop as it is drained. And to see just how low the voltage can drop before the PS4 turns off, I'll use a variable power supply and can gradually drop the voltage. The PS4 cuts out at 9.7 volts, so a 3S battery pack will work fine, but it just won't use the last little bit of the battery. However, I realised that I could only fit 9 cells inside the footprint of the motherboard in a weird 7-2 configuration. This meant overly long wires connecting one set of the 3 batteries in parallel, which results in a huge voltage drop of 1.3 volts under load. So I decided it had to be a 3S 2P pack. But I'll do this using 18650's bigger brother, the 21700. These cells are 5000 mAh each, so the pack will have only a slightly smaller capacity, and the footprint is smaller and fits nicely. That's the 12 volt requirement taken care of, but as for the 5 volt requirement, I'll use a buck converter to drop that 12 volt down for those. Now the console is running entirely on the battery pack. Let's see how much playtime we're going to get.
Gaming, 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 all the day I'm gaming. You only get the best of the games, yeah!
There she goes. Almost an hour and a half, not bad. Checking the battery pack voltage, we see there was only about a quarter of a volt drop under load, and only about 20% power left in the battery. I'm happy with that. For the power management, I'm using a 20 amp BMS, a dedicated lithium battery charger, which will charge the cells properly. However, the Max 745 needs a higher voltage than it outputs, so I'll have to bump up the 12 volt input with a boost converter. That way I can use any 12 volt charger over 2 amps, but it also means I can use a larger 12 volt charger to power the console and charge the battery simultaneously. Then I just need to add a reverse diode to the circuit to prevent reverse power drain. Now I want to be able to disconnect the battery from the load, so the screen doesn't stay constantly on, but also for safety. There's no room for a DC switch, but an AC switch should be fine, especially as this doesn't turn the console on, it only disconnects the battery. And finally, I'll add a battery indicator. This is the diagram for the power system. With 12 volt power coming in from the charger, it gets bucked up to 15.8 volts for the charging board, which outputs a stable 12.6 volts for the battery, where I can choose which one of them sends 12 volts to the ps4 and to the buck converter to give 5 volts to the LCD and ps4. To house all the components, I'm going to use the power of 3D printing and the power of friendship, because I'm using my housemate's printer. Step 1. Measure everything. Step 2. Teach self 3D modeling. My friend said I should take a class and learn it properly, but my ADHD said, get out of my way. I'm going to mount all the components using screw inserts, so everything can be secured well and taken apart easily. Sorry, hot glue. Because the joysticks stick up above the screen, I'm going to use a design that most modern controllers have, and make a protruding hump. I'm trying to make this build as compact as possible, so it's going to be pretty boxy. Now I was going to place the touchpad button in the middle above the screen, but it was too much of a stretch to reach it, so I decided to split it in two and put one on each side to achieve symmetry and give the option for either hand. The rear housing is mostly comprised of the battery pack, the heatsink and the fan. I designed the air intake at the back, with the exhaust channeling to the top of the console. But this had some problems, with only a small exhaust and a hard turn before hitting the battery. So I redesigned it to exhaust out the back, with a larger grille and a scooped channel. And so the intake wasn't sucking back in warm air, I switched the intake to the front and sides, like the original console. Now test prints in PLA are fine, but for the final shell I'm going to need something that withstands the heat output of the PS4. So I'm getting the experts at PCBWay to print it in resin. I selected Power Dark Black for the outer shell, as it has a nice surface finish and decent resistance to high temps. But for the internal parts I chose Somos Taurus, as it has even better thermal properties and these parts are going to be closer to the heat source. I upload my designs and print, and they look awesome. However, I didn't realize how flexible the Somos Taurus prints were going to be, and it's not really a suitable choice. Now, because I'm too impatient to wait for a replacement, I stupidly try and print the internal parts myself, which didn't go too well, even with a precision crafted printer enclosure. But I worked out if I printed large parts in smaller pieces, I would get decent results. Once I glued it together, it looked great. If you ignore where I glued my finger to the side. Strength isn't a concern, as it's all been glued into the rear housing anyway. Next, I glued some standoffs for the M.2 drive, so it has clearance from the board. I'm mounting it upside down so the wiring isn't crossing over. There's only just enough room to have clearance from the board and fit underneath the shielding. I also need to wire up the HDMI cable, as the ports were too thick. Okay, time to assemble this thing. I'll firmly install all the screw inserts with some added epoxy. The power button and speaker module needs to be split in order to squeeze it in. I'm using the original options and share buttons. I just need to glue on some feet, then install those along with the two touchpad buttons. Then the volume brightness control, headphone jack, and PlayStation button. I'll clamp the charging board down and stick the speakers in. Before installing the display, I need to remove the touch panel because it's too thick. It's a big slab of glass that makes up about a third of the screen's thickness. I'll mount the screen with some double-sided adhesive on the border, but I'm also going to clamp it down. I hardwired the HDMI cable for testing, and I don't want to redo it, so the PS4 is tethered to the screen board. I'm adding low-strength thread locker to all the screws to make sure nothing comes loose. I forgot to add a cutout for the controller's reset button, so I'll just add that now. I was able to squeeze the controller board in above the screen, which makes wiring up all the buttons a lot easier. The Carbon Flex contact boards are glued to the back of their controls. I made a little bracket for the reset button, which I'll just super glue to the frame. Alright, time to wire everything up. I was having a lot of issues with the HDMI connection. Now, an HDMI port is too thick to fit in here, but a mini HDMI port isn't. Being able to disconnect the HDMI cable means I can take the whole motherboard out if I need to troubleshoot. Now I can connect the controller directly to the PS4's free USB port. When I originally chose the power jack, it was only intended for charging, but then I changed the design to have the charger also be able to power the console, but I forgot I needed to upgrade the power jack. So I bought some new 10 amp jacks, which means I need to modify the shell. I'll wire up the buck converter with the 5V rails, glue the charging LED in place, and pop the battery indicator in. Now I wanted to use spade connectors for the main power wires, but there just wasn't enough space, so I ended up having to solder them. I covered the panels around the battery pack with a couple of layers of Kapton tape to shield it from the heat. It definitely wasn't the smartest design to have two halves to run wires between, but after getting the Wi-Fi antenna mounted and finally the fan plugged in, it was done. So I placed the thermocouple next to the battery to make sure it didn't get too hot and burst into flames. As well as some obvious graphical issues, the battery pack was getting a little bit hotter than I was comfortable with. But heat issues weren't limited to gaming, as when charging the console, the front right side got really hot too. But after opening up the console, I noticed something else even more concerning. These have just totally disintegrated. What could have caused this to happen? Was there too much heat? Did I screw them down too tightly? I'm really confused. Oh, okay. That explains it. So I bought a new controller frame and remade them. As for the boost converter, I shielded the base with 5 layers of Kapton tape, I swapped out the heatsink for a better one, and I replaced the diode for a much bigger one. As for the concerning battery temp, I increased the shielding with some extra aluminium fiberglass tape. And I added some foam around the exhaust channel to prevent air leakage. But I'm also adding a fan controller, which can increase the default PS4 fan speed by a chosen percentage. I think I'll go with an additional 40%, but I can change it if needed. But I can't be stuffed mounting this professionally. Now the battery is staying under 50 degrees, and the external temp whilst charging is much lower. And we're done. Introducing the PS4T, T for transport, or transpo. The handheld is under 5 centimeters thick, and comes in at a lean 1.7 kilograms. It has 2 powerful front-firing speakers, a 7-inch IPS LCD, all the original DualShock controls, and dual touchpad buttons. At the front there's a 6-stage battery life indicator, control reset button, headphone jack, plus brightness and volume control. There's a single USB port for data transfer and troubleshooting, a power jack with charging indicator, the original DualShock triggers, the power mode switch, and the original PS4 Slim power button. There's air intake around 3 sides, with a large rear-facing exhaust. Even with the 40% fan speed increase, it's still got nearly an hour and a half of battery life.
Gaming, 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 all the day I'm gaming. You only get the best of the games, yeah!
Because the battery pack exceeds 100 watt hours, you can't take this thing on some planes. But that doesn't mean you can't fly.